This video will look at database normalization. So what is normalization? Well, normalization is the process of reorganizing a database so that there's no duplicated data, so no data redundancy, and so that data is logically grouped together. Now, if you think about the previous video, there was an example of a shop and we had different customers buying different products, and what we saw was that in a flat file database, for example, when we had each record where a customer was buying a product, because we only had one table, we had to repeatedly type in details about customers if they repeatedly bought objects or products, and if the products were bought over and over again, we'd have to repeatedly type those in. So what we had was just one table, so you could argue that there was lots of unnecessary duplications of data, and again, because it was one table, the data wasn't really logically grouped by entity. Okay, so normalization is a process of making sure that these issues don't happen. Now, in order to do normalization, we go through three stages. So first normal form, second normal form, and third normal form. And the whole point of this is so that we can be assured that data can be efficiently updated, queried, and stored. So let's have a look at first normal form. So the rule for first normal form is that the database will be in first normal form if it has no repeating attributes or grouped attributes. So if you consider this flat file database table, and what it is doing is it's showing several students, A-level students, and the courses that they're enrolled in, their exam boards, and their teachers. So if you look at a row, for example, Bob Jones, the first row, we've got information about that student, their gender, their GCSE score, whether they have support or not, their date of birth, and then we've got the courses that they are enrolled in, the exam boards for each of those courses, and also the teachers which take those courses, which run those courses or lead them. Now, we've got several fields here where we've got grouped attributes. So we've got courses, exam boards, teacher name. These have all got grouped attributes. And the problem with having grouped attributes is that we can't actually search for particular bits of data. We can't query our database that easily. For example, if we wanted to find all the students that took computer science, we couldn't run an SQL statement of select everything from students where courses equals computer science, because each entry in the courses field contains several pieces of data. So what we could do is we could reconstruct this table to ensure that we don't have any grouped attributes. So you can see here how we have now got each row for each student, but instead of having grouped attributes, we've actually split the different courses up so that we've got course 1, course 2 and course 3. The same for the exam boards, and if I had space I would have carried that on for teachers as well. So now we could, if we wanted to, do a query and to find out whether a student was doing computer science, for example. Although we would need to run that in several courses columns. Now we've still got an issue here because in its current form we've actually got repeated attributes. Okay, they're not grouped anymore, but they are repeated attributes. Course 1, course 2, course 3, they're all repeated. And that does bring some problems. So imagine if a student wanted to drop a subject, the database would begin to have null fields, so empty fields. And if a student wanted to enroll on another course, so a fourth course, we'd have to completely reconstruct this database table in order to actually allow that to be stored, and that could be very problematic indeed. So the process of normalization seeks to solve all of these issues, and we're now going to have a little look to see how we can actually go through the steps of normalization so it can be as efficient as possible. So remember, first normal form, a database will be in first normal form if it has no repeating attributes or grouped attributes. So we've seen an example of repeated attributes. We've changed the table so it's got, we've had an example of a table with grouped attributes. We changed that structure so it had repeated attributes. But if we want to get our previous database table into first normal form, we simply need to just increase the number of records that it has so that attributes are no longer repeated. So here's an example. You can see now that we haven't got 3 columns for courses, we haven't got 3 columns for exam boards or for teachers. We've simply got a single attribute, courses, same for exam boards and teacher name. But what we've done for each student is we've actually got several records for each student. So Bob Jones is now on 3 different rows, 3 different records, and each record, it shows the course that he's enrolled in, the exam board that goes with that course, and the teacher of that course. So this table can now be easily queried. Each field contains a single piece of data, and if a student were to either drop a course or enroll in a new course, we'd just simply delete or create a record. So there'd be no instances of empty fields. We wouldn't need to reconstruct the table in the future. So this is an example of a database in first normal form. But it's not perfect. Okay, there's still lots of repeated data, lots of redundant data redundancy. So they've got the same data stored in more than one place in the database. So we've gone into first normal form. It's now time to see if we can go into second normal form. Now, just to sort of put this into sort of an example that we've seen before, if you look at or think about the video that we had previously where we were looking at relational databases, we had a look at a database for a shop, and by splitting that database up into several tables and then linking them together, that is the process of going into second and potentially third normal form. So we've got our flat file database here. It's okay, we can query it, but it is not that efficient. So let's have a look at how we can turn this database into a more efficient one by going into second normal form. So second normal form is where a database is already in first normal form and is also in a state where all of its non-key attributes are dependent on or related to the primary key. Now that sounds really confusing. So the best way to get around this is to have a little look at an example. So we're back to the table that we looked at before. So this table, as we know already, it's in first normal form. It's not as efficient as it could be. And the reason why it's not efficient is that Bob Jones has to be manually written into this table on 3 separate occasions, or Sally Rose does, or Jane Durkin, and so on. And the reason why it's not good to have this duplication of data, as we sort of discussed in the previous lesson, humans are prone to making mistakes, and if you incorrectly spell an entry somewhere in the database, it will be unsearchable. More storage is required to store the duplicated data as well. Not great. So to overcome this problem, we can split the table up so that each entity has its own table, and then we can link them together. So we said before, this sort of confusing statement, a database will be in second normal form if it's already in first normal form and is in a state where all of its non-key attributes are dependent on or related to the primary key. What we're talking about there is that each table has to hold data about a single entity. So the attributes of the table should all depend or relate to the primary key, the entity itself. So each column within the table should depend on the primary key. Each table should be about an entity. So what we're going to see now is an example of turning the previous flat file database into a relational database. So it's in second normal form by splitting up splitting it up into tables about each entity. So here we've got an example of a table just about the students, and you could see here that each student has its name, gender, GCSE score, support that it has, date of birth, and that information definitely does relate to the student. We've got courses here, the different courses that are run at A level, their exam boards, and the teachers that run it. So on the face of it, looks like that all relates to the course. So we sort of split them up into two tables, and then we could have this sort of intersecting table where we can start to link them up. So each enrollment, for example, a student going into a course is an enrollment. We could have an enrollments table. Now, if you actually study the courses table in a bit more detail, you can see it's still not in second normal form. You could have a situation where a teacher teaches more than one course. So therefore a teacher isn't dependent on the course. And because of that, we need to split this table up even further if we want to get it into true second normal form. So a teacher is actually only really dependent on its ID. It's not necessarily dependent on the course. So let's split it up even further. So now we've got an example where we've got our student table, we've got our courses table, and we've got our teachers table. Because now that we've got our teachers separated, if a teacher was to teach more than one course, then their ID could be placed in the appropriate record. Much better doing it that way than having to repeat teachers' names over and over again. So if we want to go to second normal form, it's about all of the attributes in each table depending only on the primary key. So this database is in second normal form because it was already in first normal form and is now in a state where for each table all of its non-key attributes, all of its columns are dependent on or related to the primary key. And usually at this stage, when we go through the process of normalization, it's often also in third normal form, but we do always have to check, and that's really important, certainly in an exam. Well, obviously in real life it's important, but in an exam it might be you get to this point and you just need to do a double check to see if it's also in third normal form. So what is third normal form? So third normal form is where a database is already in second normal form and contains no attributes that, in addition to the primary key, also depend on another attribute in the table. Again, confusing. So let's see if we can see an example of what this actually means. And here's another definition, which is probably a little bit more confusing. In third normal form, all of its attributes are non-transiently dependent on the primary key. Let's see if we can understand what that means. So we've got our tables that we had before, our relational database. Now if we go through each one, the course, the exam board, the teacher ID all depend on the course ID. They are not also dependent on any other column. So the course, computer science, the exam board, the teacher ID, all of those are dependent on the course ID and they're not dependent on any other. So that's fine. Here, the teacher name depends on the teacher ID. It does not also depend on any other column, and in this case there aren't any others. The student ID, the course ID both depend on the enrollment ID. They do not depend on any other column, so that's also fine. But let's have a look at this, and hopefully this is where the penny drops when we are talking about third normal form. In this table here, with our student name, gender, GCSE score, support, date of birth, it says that the student name, the gender, the GCSE score, support, and date of birth all depend on the student ID. Well, we know that. It's in second normal form. However, support also depends on another column. Support depends on their GCSE score. Whether this student gets support or not depends on the score that they got at GCSE. In this case, if it's less than 100, they need support. If it's more, they don't need support. So yes, support is dependent on the student. Their GCSE score belongs to the student, so it's dependent on the student ID. The date of birth, gender, and their name, definitely all dependent on the student ID. They all relate just to the student ID. However, support also relates to GCSE score. So this is in second normal form, but is not yet in third normal form. So a database will be in third normal form if it's already in second normal form and contains no attributes that, in addition to the primary key, also depend on another attribute in the table. So here's an example of getting that previous student table that was in second normal form into third normal form. We split the table further, and now we can see and say that each table contains no attributes that, in addition to the primary key, also depend on another attribute in the table, as we've removed support and GCSE score fields. So now what we've got is our student table, we've got a support table. Whether they get support or not is dependent on the GCSE score. Both of those things are dependent on the support ID, and then we can put the support ID into the student table. So our database is now in third normal form, and here are the relationships. So in summary, first normal form, the database will be in first normal form if it's got no repeating attributes or grouped attributes. So getting that table into a flat file database with each record having no repeating attributes and no grouped attributes, that's the first step. If we want to then go on to second normal form, it's about making sure that we identify what the different entities are and split the database up into separate tables, each table being about an entity. And then third normal form is a very tricky step whereby we look at each of those tables that we've created in our relational database, and we ensure that each of those attributes, that they don't, in addition to the primary key, also depend on another attribute in the table. And if they do, we split it up further.